The chain rule is the method we use to differentiate functions of another function. And it works sort of like fractions, that if we have dy by dx, I can rewrite that with a matching numerator and denominator, because if I think of these as fractions, what I've got on the top matches with what I've got on the bottom, so they would cancel out. That's not exactly what happens when it comes to differentiation, but it's a useful comparison. So what do we mean by this? So let's look at this example. So I've got y equals 3x to the 4 plus x to the power 5. Now I could say that this is basically something u to the power 5, where u is what I've got in brackets, 3x to the 4 plus x. Then the chain rule says if I differentiate y with respect to u, which is a standard polynomial, so that's 5u to the 4, and I differentiate u with respect to x, sorry, that's u, not y, I get 12x squared, so x cubed, plus 1. Then I can put them back together according to the formula. So dy by dx equals 5u to the 4 times 12x cubed plus 1. However, our original function didn't have a u in it, so our derivative can't have a u in it, so we need to substitute back in u in terms of x. So dy by dx is 5, u, which is our bracket, multiplied by 12x cubed plus 1. That's a very long-winded way of writing it, and using the extra variable u is then made more difficult when we come on to product rule and quotient rule. So it's ideal if we can learn to do this without having to write it all out. So the basic idea is that if we have some function of x to a power, then we differentiate the power in the usual way. So we get multiplied by the old power, reduce the power by 1, and then we multiply what we get when we differentiate what's in the bracket. So if we look at this second example, I've got y equals, now instead of writing it with a square root, let's write it with a power to the power of half. So the chain rule is telling me that I'm going to deal with that power just as I would normally with differentiation. So I'm going to multiply by that old power and then reduce the power by 1. 1 less than a half is negative a half. But then I've got to also multiply by what I get when I differentiate the bracket. And if I differentiate 5x squared plus 1, I get 10x. If I write that a bit more simply, a half of 10x is 5x. I have 5x squared plus 1 to the negative a half. And I want to find that when x equals 4. So substitute in 4. So dy by dx is 5 lots of 4 times 5 lots of 4 squared plus 1 to the negative a half. 5 fours are 20. 4 squareds, 16 times 5 is 80 plus 1, so that's 80 to the power, 81, sorry. 81 to the power negative a half, which is 1/9. So I end up with 20 over 9.